of variables. Direction of variables. Direction of variables. It homogeneous. First order. Right? We did linear. Go check out our videos on YouTube. We did this, right? Now, in this class we want to focus on the basic of second order differential equations, right? A simple second order or a general equation. Second order is a y over d squared plus b y over c y equals 0. This is a basic, right? This is a basic of a general equation for the second order differential, right? In engineering, second order can be expressed in examples, right? Can be expressed in examples. First one, right? First one is the equation. The second one is the called mechanical systems. Mechanical systems. And the third one is the deflection. Deflection profile. Right? Profile. Now, let's try to take this equation, the general equation, make it in terms of electricity, in terms of electric. Right? So now, this is application in electricity. When you apply second order in electricity, the equation can be expressed like L d squared Q over dt squared plus R dy over, not dy but dq over dt plus 1 over c q. This is equals to 0. Now, where L represents what? The inductive or the inductor. R represents what you call the resistor or the resistance. Let's just say the resistance, right? C represents the capacitor or the capacitance. Q represents the charge. T, you know, this is the time, right? It means you're differentiating in terms of time, right? So now, with respect to time, so mechanical systems. We come to mechanical systems. In mechanical systems, you'll be hearing more often 3 words. In mechanical systems, you'll be hearing more often 3 words. The first one is the mass, and the second one is the damping. The third one is what you call spring. You'll be hearing these words more often when you come to mechanical systems, right? So you need to know this, and then this one, very rare that they can ask you a question like this, but most cases what they emphasize you to know is the mechanical and the electrical systems, right? So now let's move. In this case we'll be expressing this as m d squared s over dt squared, which m represents the mass, plus b ds over dt, where b represents the damping, plus ks, where k represents the spring or the spring constant, right? This is equals to what? 0. Some books will say spring stiffness, right? So now, m represents what? The mass. B represents damping. Then K represents spring stiffness or spring constant. Some books will just say this is a spring stiffness. Right? S represents the distance. Right? S represents the distance. Right? So now, finally, let's talk about this one. But in most cases, what you need to know is this one and that. Let's talk about the last one. Then we will be done with a basic introduction of the second order differential equation. Right? And this one you have d squared y over dx squared plus p over e I y. This is equals to 0. Right? This one, you'll be dealing with it more often when you are doing strength of material. Right? So, now, let's try to name these things. P represents the load or the force. Right? E, we all know E, it's Mr. Young's modulus. Right? I represents the second moment of area. Right? Then, what did you leave? Okay, I think that is that. So now, make sure to subscribe, like, share the content with your friends, and most of all, enjoy our videos as we will be posting more and more videos like this. Don't forget, we are on 1,950 subscribers. Let's try to make it to 2,000 subscribers before the end of May. Danko.